I guess we better start. Good afternoon. Welcome, everybody. My name is István Cherry. I'm the development manager for the application platform for Windows Phone. I'd like to walk you through the Windows Phone architecture, what changed since last release, what direction we are going. And basically, I'd like you to walk away with a deeper understanding of what the platform architecture is, what did we add, what were the extension points, and what can you do to actually enhance your applications for this platform. This is the high-level component architecture of the phone. If you were here last year, how many actually have you been here last year on this talk? All right, so a few of you. It will be interesting to see what do you think, how well we actually extended the platform. The idea being we have the same components, we are building on the same architecture. In Windows Phone 7, we actually rebuilt the architecture from ground up. We basically created a new application platform, a new UI model, new kind of services using the C kernel. And this year, actually, in this release, we are going beyond, but we are building on the same foundation. Here are some of the highlights. I just wanted to give you a quick overview of some of the major improvements we are doing in this release compared to last release. Multitasking improvement, obviously, was one of the most sought-after features. XNA and Silverlight integration, Silverlight photo support, new SOC, I'll talk about it a little bit, and so on and so forth. As we go through the architecture, we start with the hardware foundation. This is obviously what the phone is built on. Here you see an example of the chassis specification. You notice that we standardize on the same, on one resolution this time. Last year, we were actually contemplating using multiple different resolutions. This year, we standardized, by now, we standardized on 800 by 480 resolution. We are adding new pieces to the chassis. One of them is gyro. It's another component. We are also adding a new SoC, the 7X30, in addition to the 8X55. But otherwise, this is the same platform and the same principle applies, which is we want to make sure that we have a good hardware and software ecosystem working together, where hardware vendors can innovate and create new capabilities, make the phones more capable, make the phones cheaper, if that's what it takes. At the same time, you want to make sure that you developers can develop your application and you don't have a fragmented platform, so you actually have your market pretty large. Now, when we move into the software architecture, one level up, it is, of course, built on the hardware foundation. We have the modern C kernel here with security networking, which we are taking advantage of for our application model, storage, obviously, and here is the rest of the hardware BSP, which give you access to the hardware and gives you the abstraction, device drivers, and so forth for the application platform to access on top of that. The application model is giving you a first-class access to the phone without jeopardizing the end user's experience. One of our major goals for this platform has been, that end user is king, and the end user should never regret installing an application. And that has multiple aspects, right? One of them, for example, is that the user data is protected. Another one is that the battery life is good, and so on and so forth. As we go through the presentation, I will highlight some of these aspects of end user is king, and we want to make sure end user never regrets installing an application. There is one new item here you can see, which is data sharing. This is new this year in the platform. We didn't have that last year, in the last release. In the UI model, we are using a modern page-based UI system. Now it's, of course, familiar to you. Now the phone is out. You have been able to play with it, and you could enjoy the smooth and performant features of Windows Phone 7. We have deep integration with the hardware. We are taking advantage of the GPU, both for the compositor and other aspects of the UI rendering. We also have cloud integration, obviously, built into for the phone. We integrate with Xbox Live, with Bing, Windows Live, and of course, your applications can also integrate with third-party services on the cloud as well. That is, of course, now come to the application layer. Here we have the managed frameworks, giving you access to the platform functionality and access to the cloud and all the other components you need to write the most successful applications. This is built on the CLR, which got enhanced this year. If you saw Scott's keynote, he also mentioned that we have now generational GC, which improves the responsiveness of your application, whether it's a game or a normal application. You don't get the same pauses sometimes you ran into in the previous platform. There are two new items there as well, user data and structured data. I'll talk about that in the next couple of slides. And if you notice, Silverlight and XNA is in now one box. We integrated this year Silverlight and XNA together, so you don't have to choose. You actually can take advantage of, for example, Silverlight rich text rendering in a graphics-heavy environment where you want to take advantage of the GPU, and vice versa. You can use 3D UI if you want in a Silverlight application, because you can use the same elements, whether it's Silverlight or XNA. We also have HTML5 integration. If you saw the keynote, Joe mentioned that we have IE9-based HTML support in the platform. Just like in the previous release, the HTML control is available, and you can integrate it into your application. So if you want to use modern HTML5 features, you can in your application. It's well integrated. And of course, on top, you have your application UI and logic. Now, going back to the frameworks a little bit, this is the framework stack. You can see the high-level componentization here. I highlighted some of the areas where there are some new additions. We added over 1,500 new APIs this year. Some of the major areas are, again, here, multitasking, Silverlight 4.0, structured data, Silverlight integration with XNA, and sockets. I just highlighted some of them. This is not the full list by any means. I just wanted to give you an idea that compared to last release, we are extending the release quite a bit. We are building on the same foundation, but we are extending it. The application model is one of the areas where we took the existing application model. I'm going to quickly walk you through it and extended it, which I'm going to talk about quite a bit when we're talking about multitasking. Applications are running isolated to protect the user's experience and protect the user's data, whether it's the application data or the user data on the phone. Applications run in their own isolated processes, in isolated domains, in application domains. We only install licensed applications on the phone, and we can also revoke them. This is basically the well-known and actually fairly well-working environment we shipped in Windows Phone 7. What's new in Mango is that we added a new item called Mango, a new component called agents. And these agents help to improve your application experience, and I will spend quite a bit of time to talk about that in the future. These agents share the same sandbox with the processes. They have access to the same isolated storage. They have the same capabilities. And they basically enjoy the same privileges a normal application would, but they work in tandem with the applications. Talking about application data access next, but let me first jump into a little demo. I'm going to run through the debugger. Let me see. Just so you see the debug output first. I'm going to launch the application. I'm going to switch application. This is kind of a fake marketplace application. To give you an idea, I'm going to use it. I'm going to do 3 quick demos. And each of the demos will use the same imaginary marketplace application to highlight some of the scenarios you could encounter. In this case, this application is using structured store. It's using our new structured storage support, which is based on the SQL Compact Engine 4.0 version, which is the same as you can now access on the desktop. If you use, for example, Web Matrix, it's using the same storage engine. I actually already synchronized and downloaded most of the application marketplace data into the database up to roughly 4 or 5 days ago, because I will show you how to synchronize that later. The database size is actually quite large. It's 0.5 gigabyte, it's 500 megabyte. And the reason is I also downloaded the icons into the application icons, and they tend to be quite big, actually, surprisingly. You can see the query here. There are 12,325 items in the database right now. As I said, I didn't sync up to the last date. This is kind of, I think, up to April 8th or something like that. You can see the application is rendering the icons. It's rendering the items. I'm going to scroll up a little bit. And you will be able to see the debug output. What happens here is that the application list box is virtualized. I will walk you through the code a little bit later how it's done. Here you see the new items. Basically, this is running a database query of starting with the newest items going descending order. The next pivot field is using actually the top rated items. This is using the average user rating. Unlike the previous pane here, I'm actually downloading the icons on demand. So some of them won't show up. They actually, until later, because they come through the internet. So you can see it's a little bit more sluggish. Now, this is not the optimized version yet. So before you ask, this is not the Silverlight optimized version yet. So don't take the performance into account here. This is more about the functionality. And the last one, I wanted to quickly show you a search. Here, there's a range query basically done on the price of applications. And I can bump up and down these sliders. You can see the count pretty much instantly updates as we find the items between, for example, 2 and 2.9. There are 330 of them. You can go up and can start finding the really expensive applications up there. And this is, of course, querying the 12,000 items in the database, which is actually not that many items for a database, but you can still get the idea that it's fairly quick. So this is the first demo for structured data access. Now let me go and walk you through how it actually works. So let's start with the entities of the database. We are using LINQ, which is the language integrated query version of C#, which is using the C# data context, the LINQ data context. Here I'm showing some of the entities which is contains in the database. There is an app item table. And you can see here the indexes we are setting up. So you actually can start with the code here. The point here is you can start with the code. You can start with your table. You can even define your indexes. And when we create the database based on this data context data, we make sure that the right metadata is created in the database level. These are the app item. There's app data. App data actually contains the icon as a binary. This is the app icon. And the other data is where you can see I put an index on price for the offer table. This is what contains the price, and this is what I was querying for the search. Here is a very quick look at the app database. This is inheriting from this LINQ data context. And you can see there's some debug data here, but you can see that the tables, the app item table, the data table, and so on and so forth. This is all you have to do. When you set this up and you initialize and you create an index of the database, it will create the right metadata for SQL CE. App list, very quickly, this is a virtualized list box, which is using the database. You can see that I create the database here asynchronously using the thread pool to make sure it doesn't block the UI thread. And once the database is starting, the database itself is actually set up. It has a worker thread itself, which you can submit queries, and those queries get executed in the background to not impact the foreground user application experience. You can see here I queued that work item. And let me go to one of these queries just to show you. This is one of the main queries I was running for paging. So that's an interesting query. What this does, it basically orders the app items by ID and release date, and then it pages basically from a current date where you say either up to that date, or if I reach that date, up to this ID, and then fetch the next page worth of items. Here is take f.count. So this is how I page through the database. If you look at the output very quickly, what happened here as I was scrolling through the list box, it was requesting items at different indices. And the way this works is that you pick up the item data at that index, and then you run a query paging from that data point. So this is what happened behind the scenes. Here's a very quick little read database. This database is basically once you queue a work item, it creates a work item, and it executes it on its own worker thread. Once the worker, when it's done, it calls back the user function. So this is how the asynchronous execution is working. All right, so let's go back to the presentation. So the point here, we can use standard list box virtualization technique with the data binding of Silverlight, with structured data access. You can take advantage of database tables and indices. Now on the phone, there's a lot of content-centric experiences. In fact, if you think about it, a lot of the real important experiences on the phone are all data related. Now, how does that work? The way it works is that those content-centric experiences have their own local storage on the phone, but they usually get the data from web services, from the cloud. So you could almost think of it that this data is almost like a cache. It's not always true, but a lot of times the data is a cache, which is synchronized from the cloud. Since it has to be stored on the phone, we have to take into account that we actually have two widely different I/O characteristic storage on the phone. The actual ROM, if you will, is eMMC-based, that's fairly fast. At the same time, the SD card is fairly slow. And we'll show it a little bit later what the performance characteristics are of these. So the challenge is here, you have to take into account the different I/O characteristics. You have to make sure, again, the battery life is very important. Make sure you're not depleting. And you also make sure that as you are fetching the content from the cloud, you make sure you take into bandwidth and network utilization into account. So now a little bit more detail how it works. So you have the content-centric experience, your application. It has an application local storage in the isolated storage. Or in case of the phone built-in applications, they have their own storage. And there is a sync agent which synchronizes with the cloud, usually with the web service. Now, to make this phone health-friendly, we actually use a task scheduler to launch the sync agents. And this task scheduler has fuzzy timing, where you can align different requests to make sure, for example, you don't wake up the radio every 5 seconds. You actually can tell the system, look, I will need to do some network activity, wake me up with this certain tolerance, and then the system will wake up the task, and it will execute it once the other tasks are aligning as well. Now, this task scheduler is working in tandem with the connection manager, which is taking care of what network stack you use, whether it's 3G or Wi-Fi. It works with the resource manager to make sure that the memory and CPU utilization is in the right boundaries. And we have a power monitor which detects when the phone gets low on power, and you can shut down certain activities, warn the user, and so on and so forth. Now, some more about the structured data and I/O performance. Your application already had to deal with storing data in the isolated storage already in 7. So you already had to deal with the different I/O characteristics, and you actually had to do your own data storage and your own data parsing and so on and so forth. Again, this is a reminder that we have, again, widely different hardware characteristics, and you can see that even between different cards, you may have different I/O patterns. So the lesson here is you have to make sure that your application is robust and resilient against these different hard I/O characteristics. In Mango, we introduced, in addition to your isolated data support, we're introducing structured data support. In order to take advantage of some of the I/O patterns, we allow both read-write and read-only databases. The read-only databases can actually be bundled with your application package, and so, of course, you can also update them. These are usually reference data, which you want to bundle with your application. You can then take that data, and you can either copy it to your isolated storage area if you need to, if you want to modify it, because maybe you just want to use it as a snapshot or as an initial value, or you can actually leave it in this read-only form, and you also have read-write databases. So I mentioned already, we are using language-integrated query to access the database. One of the advantages of this is that it gives a high enough abstraction that we're actually free to optimize the data access pattern, the data access stack beneath it fairly easily. If we want, for example, we could even swap out the database later if we need to. You can see there again the app agent is showing up there. The application agents can actually share these databases with the foreground application. If the agent is the same, basically the agent is for that certain application, you actually can access the database, and I'll show that later. Now, as we open up the application data sharing more and more, and there is definitely request, and there is definitely a tendency that we would like to get more application data integration. The challenge there, of course, is that as we would like to blur the distinction between the built-in applications and the third-party applications, we also want to preserve the isolation. We want to make sure that you cannot just blindly access any user data or blindly access any other application's data. So we want to make sure that we are in control, the system is in control of that. So the way we make that work to allow content sharing for applications is that applications, as they store data in their local store using Link or the isolated storage APIs, and the built-in experiences, they have their own phone storage, we create a new service called a data sharing service through which you can actually basically exchange a token, and based on that token, you can get authorization to access the data. So now we can carefully orchestrate this and make sure that some of these experiences start gradually opening up, as we also want to make sure that the user is always in control and you don't get any surprises. This is, again, going back to the principle of the end user should never regret that end user installed an application. You don't want to install something which then accesses all your phone data and uploads it on the cloud. The next, of course, once you have all this data, you have to also present it to the user, and this is where the UI model comes in. In Mango, we are taking the UI model to the next level. One way to think about it is we are rethinking multitasking. At the same time, we have unique challenges because we want to make sure that we keep the existing Windows Phone UI great. If you look at Windows Phone 7, the UI is fluid, you have high 60 frames per second animation rates, and in general, you have a very great experience of the foreground applications. At the same time, since the hardware is getting more and more powerful, and you get more and more memory on the phone, we also wanted to make sure that you can get more out of the phone. And we'll talk about how it's done, but in general, the expectation is that you can get more out of these phones than, let's say, you could do 5 years ago. And the third part of the third principle here is don't keep the user waiting. Let's make sure that we enhance the user experience. When the user wants to switch back to a previous user's application, let's make it as fast as possible. Let's improve that experience. Now I'm going to do another quick demo about user experience here. This is going to be an agent. Actually, I'm going to start this time with the phone. So the way this is going to work, that again, in this imagery marketplace application, has an agent. And what this agent does, it runs in the background once it's scheduled, and it downloads the newest applications from the marketplace and adds it to the database in the background. Then the foreground app, of course, can go and get that data from the database. What I'm going to do, actually, is I'm going to launch the agent. Now, this is a special version, of course, of the phone. When I launch the agent, it doesn't mean it's immediately launched. It's just scheduled. But in this device, there is special fixes there. So actually, the agent is launched fairly quickly, so I can show you how it works. So I'm going to launch the agent. And of course, this is where I run into a bug. Let me try the other phone, because that doesn't look good. Let's try this one. Just make sure it's the exact same data. Again, 12,325 items. It's actually interesting to note, look at the items, 12,325, and the newest is 4/8/2011. So now let's launch the agent. Wow. That's interesting. I wonder what's going on here. I guess let me try to reboot the phone and and we'll do this demo later. Let me quickly walk you the code, though, and we'll do the demo later once the phone rebooted. Let me walk you through the code, how it actually is supposed to work. This is how the application launches the agent. It creates a new periodic task with the agent name, and it basically schedules it with the service. Once the agent is actually scheduled by the system, it would show a toast. This is what you will see when I show the demo. And then you can see that it actually creates a sync version of the application database data context with the parallelization of 5. This is the parallelization actually when I'm downloading icons and app data that do it 5 at a time in parallel. And then once it's done, when the count change is coming back to the database, that the database indeed updated, it would actually update 12 app items at a time. Then it would send a toast that it's done, and the agent would go away. It notifies the system that it's complete, and it basically runs in the background, updates the application data. When the toast shows up, you can click on the toast, and then the application launches again. So let me try this again. Let's see if you get luckier this time. Again, let's just make sure we have the data properly there. Okay. Okay, now the agent is launched. Now I exit the application. And now the agent is actually going to the internet. It queries the marketplace, puts 10 items. As you can see, it stopped. It set the toast. I click on the toast, then it launches the application. Actually, in this case, my action launched the application, not the agent, just to make sure there is no misunderstanding. I'll stop the agent because now we should have 10 more items. If I go to new, you can see there is 35 items now instead of 25, and you can see the latest date showing up there. So the agent updated the database in the background. Okay? All right. So let's go back to the presentation. So going back to keeping the UX great, what are the principles we need to uphold? One of them, we want to make sure we have smooth animations, we have glitch-free media, and we'll walk you through what it means in practice. I mentioned already never regret installing an application. In this case, what we are talking about here is a battery life. We want to make sure that your agents or whatever mechanism we are using to enhance your UI experience is not depleting the battery and not making your phone unusable. This is very important, and we'll talk about later why. And last, the state management and CPU, we have to make sure we are governing these experiences properly so we are not degrading the end-user experience. In Windows Phone 7, we had the following state management concepts. We are not actually changing them. We are improving them and somewhat augmenting them. Let me quickly recap how this worked. So you launch an application. It has its UI. As you navigate away from that application, because let's say you're launching another application, the system gives an opportunity to the application to save its state. And the system will hang on to that. As we are launching more and more applications and we are launching pages, every page and every application instance gets a chance to save its state in case we have to remove that application from memory and it has to restore its state. So for the end user, the experience is as seamless as possible. So we are launching more and more pages. As we navigate away, now we are launching the third application. Now in this case, let's pretend that this application is using so much memory. This is a foreground application, so it's actually allowed to, that we have to remove the very first application from memory. Now you see that the state stays in memory. As we are navigating backwards, these states, of course, gets removed because now the application is not using it, but the very first application can use it to restore its state. So the bottom line is the navigation stack and the state is retained by the system, and it's managed by the system. And one way to think about it, we are virtualizing the applications. We are not using paging in this case, but instead we are using their state. We are hanging on to them and hand it back to them so they can restore their application state. And this application UI, actually, the processes can be potentially discarded. And this is where the improvement comes in. Have you seen Adina's talk about fast application switching? This is what we improved in Mango, and we'll talk about it in a second. Let's talk about CPU management. How was it working in Windows Phone 7? In Windows Phone 7, now what happened? Huh. Oh, there it is. These were the major thread priorities in your application process. We had the rendering thread, which occasionally could run actually above the normal priority to make sure that the rendering happens. The UI thread runs at normal priority at 4 millisecond quantum. A quantum is the allotted time for a thread to run before the system will preempt it and switches to another thread. The thread actually is, or the application is always free to actually give up its quantum earlier, but if it doesn't give up, the system will make sure it gives it up after the quantum is expired. And the background thread runs at normal 2 milliseconds. So these are the thread quantums actually in 7, Windows Phone 7. Now, the reason we pick these values, we have to make sure animations run every 16 milliseconds to get 16 frames per second speed. And video runs at least every 33 milliseconds or 41 milliseconds, depending on how fast your video is going, whether it's 30 frames per second or 24 frames per second. On your UI, of course, happens the normal UI operations, usually. Data binding, touch events are actually serviced by the UI thread in Windows Phone 7. And your background activity, which is doing, let's say, the background download, which I was using in my application here, is usually trying to occupy the idle space. Now, of course, what happens if you use a lot of background threads, they can actually overwhelm the UI. And this is not a good ratio to have. For example, if you use 5 background threads and they all use their quantum, they will get to run 10 milliseconds, and now your UI thread only runs 4 milliseconds, so the ratio between the UI thread and the background is actually pretty bad. Now, how does it work in Mango? So in Mango, we changed these ratios. We made the rendering thread 8 milliseconds. Again, it runs sometimes at higher priority. The UI thread now gets 20 millisecond quantum to make sure that the UI operations continue and complete. And the background runs at 4 milliseconds. Now, you can see that touch also is now handled in the rendering thread, which means that even though we bumped up the quantum from the UI thread, touch is still responsive because we are handling it in another thread, so it gets the right frequency. And you can, of course, see the ratio that between the UI thread and the background thread, the ratio is now 1 to 5. So even if you run 5 background threads, they get roughly the same amount of time as the UI thread, which is not bad. So this is how we're changing the system in Mango. Now let's talk about memory management in a little more detail. I walk you through the high-level application virtualization. This is how memory works. So in 7, we had 256 megabyte of limit for basically this was our minimum chassis requirement for memory. Some of that memory is used by obviously the OS, device drivers, so on and so forth. And we said every application should be able to run in 90 megabytes. This is our recommended setting for applications. The rest of the memory is used by the backstack, used by the file cache of the file system, or other periodic activity by the system services. And so the idle time is basically, it's not really utilized. It's actually idle. It's not idle time. It's idle. It's not really utilized in 7. Except by some of the activities. Now, in Mango, we didn't change the memory unit actually in Mango. We are still aiming for 256 megabytes of memory. But now you see a new item on the top. There is apps. So apps can actually now start using this unused idle space in Mango. Besides the backstack and file cache, applications can also use this space. And this space, when it's used, actually can be always evicted on demand. So if the system needs space, it will evict applications from that space. Just like today, the file cache, for example, gets evicted if it's needed. Applications, if they use that space, they get evicted. Now let's talk about battery life, because this is a very important point. Battery, unlike other resources on a phone, are special. If you exhaust memory, you can always recover memory. If you use too much CPU, you can always stop using too much CPU. You can always recover the CPU. That's easy. At the same time, though, if you depleted the battery, it's gone. You can put it back. So it's very important that we are conscious of battery management. So the way we thought about it is we basically created a budget where we said, given a certain goal for how long this phone should run, and given how certain experiences should run, we created a budget which we can utilize for background activity or multitasking activity. You can see here how much resources cost in terms of battery power. CPU, obviously a big one. It can actually go up to 1,000 milliwatts. Display, again, can go quite high. The minimum is usually 150, depending on how bright it is. And you can see the rest of the stack. You can see how expensive radio is. 750 milliwatts if you wake the radio up. That's a lot. Now, how do we make sure we get more out of the phone? As I said, we set up a budget, and we make sure that agents, which I'll talk about in a second, they doesn't exhaust more of that certain budget. Your application is a foreground application, which means we let it to grab most of the resources in the system, whether it's memory, whether it's CPU, because it is the user is interacting with it, so we want to make sure that the user gets a first-class experience. That goes back to our motto, or principle, rather, that end user is king, sorry. So we make sure that the foreground application gets 90% of the CPU, about 90% of the CPU, gets 90 megabytes of memory, and it gets basically full power. We are not constraining the power of the foreground application usage, because again, the end user launched that application, the end user is interacting with that application. So you want to make sure that's first-class experience. But at the same time, we want to take some of this application logic, which is, of course, right now, is bundled with your UI, and use it as an agent which can work on behalf of the application, just like agents work on your behalf. So these agents can execute this application logic in the background on behalf of the application or behalf of the user. But this time, we are constraining their memory, their resource usage in general. Whether it's memory, whether it's CPU, or whether it's battery, we want to make sure we constrain them because the end user doesn't interact with them. You saw in the demo, I launched the agent, I scheduled the agent rather, and then it runs in the background. The end user have no idea what's going on. And so we wanted to make sure that the end user doesn't have to worry about what's going on in the background. So that's a very important principle. And this actually took quite a bit of work to make sure that this works properly. Now, the way it works is that the background agent basically inherits from a base class. The system, when it launches an agent, invokes a method on the agent. The agent can do its work. Once the work is done, it notifies the system that it's complete. Now, if the agent doesn't notify the system that it's complete, it will still complete, because the system will make sure that we terminate the agent if it passes its allotted time. Okay? Now, the agent can also actually abort its operation, or the system can ask it to cancel its operation. So this is how agents work. So basically, you could think of them as a component, bundled up application logic, managed by the system, executed by the system based on different schedules, and we'll talk about in a second how they work. Now, as I mentioned, these agents run in the exact same sandbox as your application. They can share isolated storage, they can share the database, they use the same capabilities, they have access to the same resources. But they are running as separate processes and running on a separate schedule. One example of an end-user experience where we wanted to make sure that it works seamlessly is the audio agents. And the system currently, the current built-in experience is using the Zoom Media Service. You get background play of audio. You get background. You get integration with the UVC. You get basically first-class background experience. We wanted to allow third-party applications to have the same experience. So we allow audio agents to participate, you could think of it this way, in the audio pipeline. Now that means that they can be launched by an audio service. They can participate when tracks are changing. They can participate somewhat in the queue management. and they can basically play audio in the background. The agents can also participate actually in an audio pipeline even more directly by participating in decoding the audio. These agents then will be permanently running in memory, and they can actually run in the background. So if you put it together, you see the audio agent, it's integrated with the UVC, the universal volume control. You can see what track it's playing. It's fully integrated into the system to get a first-class audio experience. You can see here that we are reserving, you could think of it almost like a slot in memory for the audio agents to make sure it can run and it can finish, or actually it can continue its work. Now, the audio agents are somewhat special because with the audio agents, the end user is aware of the activity, what's happening in the system. You see it in the volume control, you see it in the UVC. You actually hear the sound. So we actually let the audio agent to get a little bit more resources than normally we would let other agents. And the main reason is because the end user is aware of this activity. However, there are times where you want to make sure that you have more generic ability to execute code in the background. Now, in this case, though, we want to make sure that, as I said, we are maintaining the principles of not using too much resources, not using too much battery. So we are actually constraining these agents, but they are generic. You can run generic code, and they will execute in the background. So the way this works is you have the normal audio agents and audio service, and now we introduce a new kind of agent called periodic agents. And this is what I was running in the demo. These agents run by the system from time to time. That the actual time will be based on the budget. We are still finalizing it, but as I said, we have a power budget, and really the power budget is constraining how often we can run these agents. But you could think of them, they will run roughly, let's say, every half an hour. They get a certain time, 10 to 15 seconds. They get to do their work, and they go away. So these are periodic agents. The third class of agents, which we are adding to the stack, is the on-AC agents. These agents are the ones which will be launched when the phone is on AC power, has Wi-Fi access, and basically it's idle. Then these agents can run. They can actually run for a considerably long time, and they can basically use almost as much resources with certain caveats as they want, since there is AC power. The scenario for these is, for example, downloading feeds for the morning, or in my case, in this imaginary marketplace application, would have been that every night you download actually the new applications. Instead of using a periodic agent, you would use these own AC agents. So by the time in the morning when you pick up the phone, the latest apps are in there. This would be the scenario for the generic agents. Now moving on to the don't keep the users waiting. This is the case where in 7, as you know, we tombstoned the applications, third-party applications, when the user switched away from them. One of the reasons was we wanted to protect the end-user experience. In Mango, we are actually letting these applications stay in memory dormant. Now, what that means is they are actually not running. One way to think about them is we cache the applications in memory. We actually freeze their threads, and if they violate of being dormant, we actually terminate the application. Now, it's still true that the application can restore its state from the state, as I showed in one of the previous slides, that even though we terminate the application, its state can still stay in memory, so when the user navigates back to the application, it can be restored. But now we allow applications to stay in memory. So you can see that applications, and you saw some of the demos where you show the backstack navigation and how you can pick the applications in the backstack. So you can see now this picture is getting quite complicated. It might be a good time to kind of highlight that there's a lot going on this system. You see an audio agent, you see periodic agents coming and going, you see dormant application being in memory, and this all needs to be managed by the system in a way that the end user experience is maintained. And last but not least, background transfers. There are scenarios where the current agent mechanism won't be good enough. The periodic agents may not run frequently enough, or they may not run long enough. So we wanted to make sure that for scenarios where, for example, you're downloading a large video, you can do it and the system will do it for you. And this is a background transfer service which the application can use. You can tell the background transfer service to download large data sets, store them in the file system, and then the application can access them later. It actually will, of course, go to the isolated storage. Once the download is completed, there could be a tile update or there could be a toast notification sent, so the user is aware that a certain activity is done. Right, so let's finish the UX experience with the UI composition. Let me again recap very quickly first how 7 and basically Mango works as well. The system is using the UI, using the compositor to manage the system UI, puts bits on the screen. You can see the application page, the SIP, and all these different UI elements being put together by the compositor. One of the main principles here is the reason we are using the system compositor for this is that when a phone call comes in, it definitely has to be on top. So you have to make sure that the system is managing the right priority for the UI elements in the system. You can see all the different. Now, what changes in Mango is, I'll show you with a demo first. And I'm going to show here, if it comes up. Power is on. Oh, there it is. XNA and Silverlight integration. Again, using the this marketplace application, I'm going to show you a Silverlight page where what it will do, it will load the icons from the database, the application icons, show them on the screen, and it will do a count using a Silverlight text element, actually a text block, and it will use XNA to animate the icons as sprites. So let me show you. You can see the loading of the icons. It's deliberately done actually fairly slow, so you can see the counting. And then you can see it picks randomly a set of icons, and it starts animating them. You can see it's fairly smooth, even though a lot of activity is happening in the system, even when you go up to 300 icons. All right, so that's that. Now let me show you how that works. Just very quickly, let me see how we're doing on time. We have 10 more minutes. So the way this works is you start off with a normal Silverlight page, and then when that page is instantiated, you set up these timers. You set up the XNA dispatcher. For you who are actually already used XNA components in Silverlight application, already know that you have to make sure you pump the dispatcher timer. And then we set up a game timer with a certain interval. Actually, in this build I have, you can tell the system that the time span is 0 and run the fastest possible speed, meaning as many frames a second as the system supports. And it's, of course, the goal here is 60 frames per second. You set up layout updated, on update, and on draw, just like a game. Here you can see how I'm loading the icons from the database. It's a simple query. I showed you this table, which is actually vertically partitioned from the app item table. Simply run a query, use the enumerator, and start fetching these icons. Once I have the icon image, I create a texture using the XNA texture from stream. And then I invoke this on the UI thread to actually update the Silverlight text block text. So how does the to-do come together? In onUpdate, you can see that when I touch the screen, I just tell the icon viewer to set up a different layout. So that's that. Now, when the game page is updated, so this is the Silverlight layout update. So for example, when the text blocks gets touched because I set the new text value, Silverlight forces a redraw, remeasurement, and redraw, and it calls layout updated. And at this point, we use this new element called UI element renderer, which can use the UI element from Silverlight and is capable of rendering an XNA texture. I'll show you in a second how. So this one is just initializing this UI element renderer. Now, when the onDraw is called, just like in a game, You can use the graphics device, just like in a game. Here, icon viewer draw is called. This is what does the animation. You know, it moves the icons, and it actually draws the icons. These were already pictures, remember, so draws them with sprite batch draw. And if the element renderer is not null, then I do another sprite batch and basically ask the UI, the element renderer, if it's dirty, to render into a texture, and then draw it. So now you can see that it's completely under your control. You can combine XNA elements and Silverlight elements on the same page in basically arbitrary order, and you can use, I mean, in this case I use sprite batch animation, but you can use 3D and other mechanisms as well. All right, so that was the Silverlight XNA integration demo. Now, how does this work? In a very high, I mean, it's somewhat high level here. In the Silverlight page now, you have a shared graphics context, which can be shared by the Silverlight system and the XNA system. This clicker is somewhat, okay, here we go. So the application page has a shared graphics context. You can render the XNA, as I showed you, you can render the XNA content as a direct 3 surface, and you can render the Silverlight element in addition. You can combine these in arbitrary order, of course, but this is how you can basically create this new composition. And last but not least, let's talk about cloud integration services. We have several built-in client services to interact with our cloud services. We have a location service, which lets you use augmented GPS location, a push client service, which is one of the most important services on the phone because you can do low power notification to the phone. We actually optimize this quite a bit in Mango to make sure it's more power efficient, and it allows more channels compared to Windows Phone 7. And we have the Game Foundation service, which is familiar to, which allows you to upload game data to the Xbox Live service. And this is it, call to action. Hopefully you saw enough new content that you can see that the new system will allow new scenarios. You can make your application be more performant or more functional. Thank you very much. So now I can take some questions. Yes? Which one was the chassis? So you're asking about the chassis? Flexible chassis, yeah? What is that about? I don't want to go into too much detail on this because we are still finalizing the chassis spec. But as I said, we are trying to make it a little bit more flexible compared to Windows Phone 7. But I can't really get into much detail. But gyro, for example, will be optional, which is not really surprising. But I'm just saying that certain elements will be optional on the phone.
Hi. First of all, congratulations. Really great work for
Thanks.
1 year. It looks like a new OS. Regarding content sharing, do we have the ability to offer our own content for sharing?
Or your own content for sharing?
So I'm thinking like GPS coordinates. If we wanted to share
From
with
one
other
app to
apps.
from one app to the other app?
Yeah.
Not yet, unfortunately. That is still in the future. In this release, we opened it up, but mostly about the native built-in applications and the third-party applications. But this is definitely something we are working on in the future. I mean, as I said, we are gradually opening it up. I mean, it's the same what I basically said last year is that it's a very tough problem. It's not necessarily as tough as the multitasking problem, but to make sure that you allow sharing, but it's secure, but it's not in the user's face, it's very complicated. So we are still working through those issues.
Okay. Köszönöm szépen.
So in the earlier talk, it was mentioned that network sockets were one of the things that would get closed when you are deactivated. Is there a way for you to have a network socket that remains open in the background?
No, not right now. So you are probably referring to Adina's talk about that the system actually makes sure that there is no activity in the background. You can use sockets in the agent. So when the agent is run, you can actually use sockets there. But in your foreground application, when that goes into the background, right now we are not allowing any activity, so that's why we are closing.
But also the agents are very time limited, so you can only use that for a very short amount of time.
Yes, yes. And again, this is kind of a compromise we made where we said, let's extend the system, let's make it a little bit more generic. Let's allow some of this activity go on in a periodic fashion. And as we learn more and as phones get more and more capable, I think we can think about opening this up further. But right now, that's all we could do.
When you use the download agent, sorry, can you essentially chain those? Can you make a request, let that download in the background, and then immediately when that has finished, can you formulate another one and have that go off?
Unfortunately, not yet, but this is something we are considering for the future. I mean, this would be a great scenario to say, hey, the background is, or the download is completed, launch an agent so it can do something. It's absolutely a great scenario, and we are definitely thinking about that, but it's not in yet.
Thank you.
Are we going to have access to the search button in the app?
No, unfortunately, no.
Why?
The search is kind of an interesting subject. We are still working through how that's exactly going to work actually in Mango. That's all I can say, but it's not going to be accessible by the application, unfortunately.
So I'm a CTO, and it's been a long time with total device encryption and some other features that were lost in 6.5. What are the challenges that you're facing in making this phone more CTO friendly, bringing the security features and the SharePoint features that we miss and want back?
Well, we added encryption support in the frameworks, actually. You can use public key, private key encryption. We added some of those missing frameworks, so you can actually implement quite a bit of security functionality if you need to now. So these are all built into the frameworks. I didn't mention that, but it's going to be there.
So when the tools go into beta in a month or whatever, are we going to be able to deploy those to our unlocked phones?
On unlocked, you mean non-developer?
Will it be emulator only when Mango tools go?
You can actually use those tools on the 7.0 devices, no problem. You obviously will get the new emulator, so you can use the next generation features, the current features. And as soon as we can, we'll update the developer phones to the new image, but that's not going to happen next month. But as I said, you can definitely use the tools to develop 7.0 apps, no problem on the existing phones. So you can play with the new features on the emulator. All right, I guess that's it. Thank you very much. Thanks for coming.